Hello everyone, I'm Megha Tipanna. In this YouTube channel, I'll be teaching statistics, biostatistics, data analysis, and visualization using programming languages R, Python, and SAS. I'll also be using SPSS, GraphPad, Prism, and Power BI tools. And I'll also be concentrating on machine learning algorithms. And if you're from the background biotechnology, biochemistry, molecular biology, and bioinformatics, I'll be covering those as well. So this is my first video on statistics, and the part one will be data collection. So in statistics, as a broad term, uh, it is collection of information, and once you collect those information, you clean it to get us cleaned data. So that where you use organization skills, data manipulation skills, and with the clean data, you do analysis and you interpret the results, and with those results, you visualize. That is, bring it in a diagrammatic manner. So that is representation of data. So in this video, I'll be covering data collection, and in the upcoming videos, I'll be covering data manipulation and in the analysis, I'll be teaching descriptive stats, inferential stats, hypothesis testing, uh, parametric and non-parametric tests, and normality tests as well. And also, after the theoretical classes, I'll be using one data set to do analysis and the representation of the data using one of the programming languages or the tools that I've mentioned earlier. So, data collection. So, let me give you an example first so that it is easy for you to understand the definition later. Now, I have a medicine, or I have to do some research or take a survey from patients who have cancer. So, my population will be all subjects, all patients who have cancer. So, that will be my population. Or another example, if I have to calculate height of all school going students, then my population will be all school going students. Okay, so now we'll get into the definition. It might be easy for you to understand. Complete set of items that share common attribute. So what is the common attribute that we saw from the example? The cancer is the common attribute. School going student is the common attribute. All patients who have cancer is the common attribute. All students who are going to school is the common attribute. Okay, so this population can be finite countable or infinite and uncountable. If I have to calculate heights of only school going students in particular school, in a school maybe, then it is easy for me to count. Am I right? In only one school, it is easy for me to count. But let's just say I have to calculate all the heights of the school going students in the whole world, then it is quite difficult. It is uncountable and infinite. So this population can be finite and countable, or infinite and uncountable. So when you're studying a population, researchers can either collect data from every member or a subset. But collecting data from every member is expensive and time consuming, but it is accurate as well. So it is called census. Or we can just take few samples from the population and then make inferences. So this is a population. I'm taking few people from the population, which is called sample. And with this sample, I do the research or I analyze the data and then I make some inference. Okay. And that inference is not only applicable to sample, but is also applicable to the whole population. Okay. So, how do we have to take samples from the population? So, we cannot do it as such. We have to do it in a more practical manner, statistical manner to take samples out of population. So, there are few techniques how we have to take samples from the population. There are two methods. One is probability, which is also called random method, or non-probability sampling. Under this, we have four techniques. We have four techniques. We will see this in deeper. We'll use movie feedback survey as an example to understand all these sampling techniques, which will be easier. So the first will be the probability sampling method. The first will be random sampling method. In this, you randomly uh, choose people who have watched the movie, and then you ask them how the movie was. So everybody who has watched the movie will have an equal chance in this method. Okay. The next comes the systematic method or systematic sampling method. As the If you have seen the terms initially, you will understand what it defines. Okay. Here it says systematic sampling. So every nth element is chosen. For example, there are 10,000 people who has watched the movie, and you ask every 20th person who has got the ticket. So that is, it makes sure all the audience is covered uh, from the beginning to the ending. This is called systematic sampling. And the next comes the stratified sampling. Here, you actually make sense out of the data. You actually try to make sense of the research. For example, now we are trying to take a review out of a review for a movie, right? So this movie doesn't have to be for everyone, right? For example, kids might like those movies. There are movies where kids like, but the elders do not like. There are movies where adults like, but seniors do not like it. So you make strata, you make divisions out of sample. You make categories. For example, you ask different groups like teenagers, adults, and seniors. So you take surveys from teenagers separately, adults separately, and then seniors separately. You divide them, and then you randomly choose people from that category, and you ask them, get the feedback. That is stratified sampling. In cluster sampling, it is, for example, this movie is released in multiple cities, but it is not possible for you to go and take survey at every multiple cities. So you randomly choose few cities, one or two cities, and then you only go take survey from viewers from that city alone. So that is called cluster sampling. Okay. Next is the non-probabilistic method. The first one will be in convenience sampling. So here you do it on the basis of accessibility, availability of subjects. Subjects, when I say subjects, those subjects are people who have watched the movie. Okay. If On the other example that I gave you initially, subjects are uh, patients who are with cancer. So that is what I'm trying to say. So in this, my subjects are who are easily accessible. For me, in that case, whoever watched the movie and are just exiting out of the theater, those are easily accessible for me, and you go and take surveys from those viewers. So it is convenient sampling. The next one is referral sampling. From the word, you might understand. For example, I'm taking a survey to you, asking you the feedback, how the movie was, and I asked to you, do you know anybody who has watched the movie? So you recommend me your one of your friend, and then I go take feedback from her, and then I ask her, do you know anybody who has watched the movie? So this is called referral sampling. And next comes the quota sampling. This is the non-probabilistic version of stratified sampling. Remember, in the stratified sampling, we used to create categories on the basis of age, kids, adults, and seniors. Likewise, here make non-probabilistic version of stratified sampling. For example, you make a quota that I'll ask 40 percentage of the teenagers, 40% of the adults, and 20 percentage of the seniors, or otherwise, I mean likewise. That is called quota sampling. And next comes the purposive or the judgmental sampling. So in purposive or judgmental sampling, you don't go and ask layman viewers, not everybody who has watched movies, but you go and ask to people like domain experts. For example, in this case, other movie directors will be domain experts, or anybody who's there in the field, in the film industry. Those people will be the domain expert. Other production offices, other producers will be the domain experts here. So you go and ask those kind of influential people who are in that field, and you take survey from them. That is called purposive and judgmental sampling. From this, we have completed two types of sampling techniques, and these sampling techniques will help you to say how to take samples out of the population. Okay, and now we have learned this one. So what next is, how many samples do you have to take from each population? So for that, you have to learn sample size calculation. In the upcoming videos, I'll be concentrating on sample size calculation, descriptive and inferential statistics as well, and the representation of the data. Thank you for watching. If you have any doubts, please comment. Thank you for today.